Let's check if it's working on. Okay, it's working. Cool. So, hey everyone, I am Ashish Kumar Verma, and I'm currently a Google developer expert in the field of web technologies, IIT Delhi, and software engineer at HTCD. Before my intro, this one, let's talk about the title, Shipping Chennai Project with Project FUGU. All right. So, what is it about? If not, then I'll be all or you'll be all. Okay. So this thing, Gen AI, is currently so trendy, so hot in the market right now. Let's say someone said he wants to build a SaaS product, right? You have Gen AI element in that product? Yeah. Okay. Then, so it's a web-based, right? A web-based platform. Then I think all of the slides is somewhat related to you. So most of the time, it's changing automatically. The slides are changing automatically. Okay. Cool. So in this session, we are going to be taking a look at how we can leverage web technologies, not just APIs and all. Like consuming APIs are good. Okay, we are like having a lot of things over there. But I'm also going to tell how you can reproduce cutting edge research papers. So researchers are currently like producing research papers long, and we are just like taking the research paper, the big companies, right? The big companies are taking those research papers, they're actually converting them into product and then charging you. Why can't you do that, right? And I'm going to tell the exact steps on how you can, take a research paper, then ship it to, a product, a model, and then based on that model, you can ship it to the users using web technologies. Why web? Why web? Like anyone here? Why you should use web? If you want to go to my app, you have to go to open Google Play Store, then you can go Google, and then you came across my app, then you download the stuff, right? Okay, got the context. And I'm also going to tell how web actually has the power to leverage hardware. The reason we used to use Android, like we are still using the native Android for many of the cases, but let's say some simple apps like generating a model, stuff like that, we can use, just web. And have you heard about this OPFS file system? Anyone? Like these are some of the things that web has hidden for you. So let's jump right into it. First, my introduction. I am currently the youngest Google. What? Okay. I am currently the youngest Google developer expert across the whole globe. Then we are at IIT. I hacked IIT JEE Advanced Software while my JEE Advanced exam. What is? This is like slides are changing automatically. Okay. Then I won Rashtriya Vigyanik Puraskar 2 times, and I represented, already said, Japan and national winner. So these are some of the things that I got. Next, the agenda for today is reading a research paper step by step. Now we're going to move fast. We are reading a research paper step by step, the Scratch way, implementing a paper from scratch. I think there is some, can you like, no, I'll just take the remote. Okay. So reading a research paper from scratch, then we are getting the rockstar way. We are going to take 2 applications right over here. We are going to make 2 applications. And then using Project FUGU, we're going to deploy that. And then we'll do all the stuff, right? So moving ahead, why web? I already told you why web, right? Any more questions on that? A web, you might have said that you think that web can't do this, that. Web can't use, background APIs, background fetch and all those things. I'm going to talk about that in a later part. Okay. So all of these things which we think that web can't cover is covered in Project FUGU. You can actually search this up, and I'm going to, in the later part of the end of this session, I'll give you all the APIs or the hardware APIs that you need. You can just, okay. But later on that, AI or dev, we are going to do AI with dev, okay? You can change the slide. Okay. Today, 95 of the AI companies that we have is actually a wrapper around ChatGPT. Agree or not? Okay. So they just like, hey, we are AI company? No. You can change the slide. You just know how to use the API, and that's it. Okay? And even in hackathons, I see a lot of, they say that hey, we have developed a model. And where's the model? It's an API. Okay? So this is what is happening. So some good ones are, of course, even in someone is from, you are from Microsoft, right? Even some of the friends are from Microsoft. So they also use this technique. They take research paper, the research development part. He is in research department as well at Microsoft. So they take research papers and they implement that to see how well the model is working. Then they build amazing AI features on that, and then they impose significant charges on you. Okay, this is the pattern. This is a trend because I also made a lot of charges when I learned this trick. So you can change. So these are demo of the power. So AI avatar generation, I'm not taking any product, but these are the minimum prices that you need to give, and for maximum potential uses, these are the prices that you need to give for that particular thing. Okay. Now this is one of the applications that I created to demo this thing, which is Navya AI. You can look it on Google Play Store as well. So not a production, not anything. It's just a small dummy project. Okay. You can play this. I'll play this video. So this is the avatar generation one. So you can see the audio and all the things.
3 is the third and most recent lunar exploration.
अनुसंधान संगठन द्वारा तैयार किया गया तीसरा चंद्र.
Once in a lush forest, 2
You see all these things? These are all of the projects are created from scratch. This one, like even the AI generation part and all those things, the video and all, is created from scratch. Scratch means using existing models, defining the weights and fine-tuning on top of that. And this is one of another project. So these are actually one of the things that I'll show you. You see, this is all web, and this is the web part. No sensors, nothing. Just pick and drop. It's like an Apple AirDrop, but for everyone. Because, as you said, web is cross-platform and accessible. Looks cool? No? Okay. So now let's implement a research paper, right? Now this is some of the boring part. The project was, the project was somewhat good, but this is like one of the boring parts. So problem statement 1, now you need to think with me. You need to develop an application where user upload an anime or drawing sketch. My friends told me that you don't write anime as cartoon because they will get offended. Okay, so I'm not going to do that. So you need to upload a sketch, a drawing sketch, and application should automatically add colors to it. How is it? The problem statement. You have a sketch, and this is a practical application. You have a sketch, you click a picture of the sketch, and then you're like, upload to the AI, and it's just gonna, fill colors into it. So this is one of the papers that I found out, image to image translation. So the first step is getting the problem statement right. Second step is doing I think one step is missed. You can go back. Okay, so this is, you can actually take the screenshot of this one. This is actually one of the resources that I took for every application that I'll just move aside. And then what you can do is, this is one of the papers that I found out. So you have to go Googling, Binging, Yahooing, whatever you do, you have to do it. Then I came across this research paper, which is image to image translation with conditional adversarial networks. Now, as a web developer expert or Google developer expert in field of web technology, I don't know anything about AI, right? I don't have a formal degree in AI, nothing. What I do is, I just read through the research paper and just go along it. So summary of the knowledge graph. So when you read research paper, there are some of the things that you don't know, which let's say CNN, UNet, discriminator, amazing activation functions, batch size, and all those things. Now, why I took this particular project, it is because if you create this project, most of the Gen AI stuff is going to be covered. That's why I chose like not a high level, not a low level, like a medium level project, because these are the terminologies that come in Gen AI product. All right. Now moving ahead, you need to connect all these graphs, and I'm going to come this to later. Just see, right? Because let's go back. Okay. So you need to go and connect these things while you're reading the research paper. And I know this is getting boring, right? Okay, now moving further. One more, okay. Now before you proceed, you can take this screenshot as well. While creating a Gen AI application, you need to take a look at these things as well. Okay. And now you can move ahead. Now let's do coding. Before that, why I told you all these terminologies is because in this short span of time, as GDE says, we cannot teach you everything in just 30 minutes. We can tell you that this technology exists, and now you have to go and search that what particular thing, or when you go home, you can just look these things up, and you can actually ping me if there is any doubt. So now if we go further, now this is what I was talking about. When you read a research paper, you just see, we use min-match STG with Adam's apple. You just go to ChatGPT and just write, hey, this is the thing, and this is the thing, right? You see this graph that I like, these are the exact translations of that graph, whatever lines are written in the paper. So you just do this, and there you go. Moving ahead. This has the same, the architecture, every research paper except OpenAI, which is actually the closed AI, okay? Except that particular organization, every organization kinds of like, write what their architecture are, okay? So discriminant architecture and all those things, you can actually see those particular things over there. So you just have to write as it is. So C64, C28, and if you go through these slides, you'll see a pattern in every research paper. So 4 research paper down the line you implemented, you are going to create any model that you want. Even transformers, attention is all you need and all those things. Now this is again the same thing. I've just wrote it over for reference. So when you get those slides, you can actually research about how we are translating those lines into this. So moving further. Okay, further. Architecture is there, unit architecture is there, cool. Now, this is the thing that we get. You can play the video. After we generate the model. So we have to generate the model for like 4 hours, but this was only for like 20 minutes. So this is the first iteration. So you can see after some of the iteration, you can see some of the colors pinging in, right? It's just 20 minutes of training. So this is what, and this flipping is called augmentation. So these are some of the keywords that you just need to learn. And then you can, basically create most of the Gen AI applications. Move further. You can change slide. Okay. Now the homework is for you all is to go and create a software that converts day image to night image. And what you have to do is just change the data set. The code is the same, everything is the same. Code is linked in that QR code that was there. The code, you can even go to my GitHub repository and check the code GANs. This is one of the things, converting day image to night image to evening. This feature is actually, users pay a lot for this. Like you have a picture at night, you click, it's day, it's afternoon. Isn't this amazing? Like I have a night image, and I can just click and say, convert this to morning image. Now it's a sunset, now it's a sunrise, something like that, okay? Moving ahead. So is it worth going such a difficult process? Yes, for some of the parts, because I created an application which Navya is example of low powered GPU cost, or my models run on CPU as well, right? Which is like a fine-tuned version of that. You can actually look it up. I have put some of the papers on the internet on how I'm doing that all things. So it's actually U2Net modified. You can go back further. Now it's your turn. Now we are gonna create an applications with you as well. So now you can change the slide. The problem is this only. You have to create this. So first step was, what was the first step? Finding a paper, right? So let's find a paper. What do we have to do in here? What are the features that we have? Removing background image. Then what is the feature? Getting that picture to the screen without any sensors. Like if this is a screen, I take a picture of you, and then I can do this, and it's gonna just go over there, right? How is gonna do that? I'm not like, if I don't know the paper, I don't know how I would do that, right? So this paper is called SIFT algorithm, Scalar Invariant Feature Transformation. You don't have to learn anything about that. You can just go. So these are some of the questions that we have. How to remove the background, how to create the sticker, get the coordinates of the screen. So this is one of the things, and rest is just development. You can use server sentiments and all those things. Now move further. So how to remove the background? U2Net. How to create a sticker, normal manipulation image. how to get coordinates of the screen, you can use SIFT algorithm. Okay, so you can actually take this slide as well, and you can, check it up over there. How much time is left? Time? Okay. So now, you can change the slide. So now, is it necessary to consistently adhere such a long process, like taking research and doing this, taking research, doing this? Isn't it a long process, right? A boring process. Yes or no? Okay, now move ahead. No. You can go back. Okay, here. So research paper is actually the last option, and for my case, it was the best option because I need to, go and get through the CPU usage as well, make my cost lower, so I can really, tweak my model at the base level. Now, most cases, every research paper is already implemented. Now, one of those resources are papers with code. Anyone heard about that? Papers with code? Yeah. Okay. You can actually look it up. You have to save that thing, papers with code, because it's gonna, really help you in your journey. Okay, so in already implemented, inference from weights from Jupyter Notebook, and if results are not satisfactory, we already talked about that. How many of you know about inference? What is the inference? Inference form. Inference form is basically just, you using the API. ChatGPT, chat.predict. This is the inference form. What is the weights form? Weight is just, you have that .h5 model and you convert it to inference form. You have that .h5 Keras model, then you have .pickle model, then you have .torch models at Hugging Face. This is all just that. Jupyter Notebook implementation is, we have the architecture that we coded, then we run the thing, we get the weights, and then we convert into inference model, right? So, can you see the pattern? When we are deploying, we have to convert at the end to inference. Inference is just, whatever model we have ChatGPT, we just do ChatGPT.predict. Now coming to the dev part. Okay. Now coming to the dev part. Now everyone has clear picture, not a clear picture, but let's say 60% clear picture on how to create models. No? You actually said no. Okay. Yes or no? Like how to create models, how to do stuff and all those things. Yes or no? Okay, now we can go further. Now we'll move through a problem solution approach, right? So Photoshop on web. How are we going to do that? Like the AI part is always the boring part. Now some of the things, Photoshop on web. Let's say we have a huge file on Photoshop. How are we going to store that? You know how big is a Photoshop file, .ps5 file or the .psd file? It's actually 300 MB, okay? And how are we going to store that? Some of the storing mechanism on web. Everyone has done web development over here? Anyone? How to store like on a local cache? Some of the technology that we have on web. What do we have? Local storage and session storage and IndexedDB and done? Cookies. But local storage and cookies can't store 500 MB. IndexedDB can. But IndexedDB is JSON format, right? If I'm not wrong. Okay, IndexedDB is JSON format. So we can't store, this whole data structure. Like we have layers, and inside layers we have those, binary files, byte and data image and all those things. So we can't store all of these things, right? And it isn't feasible to store those things. So on Photoshop, we actually have origin private file system. You can actually take the screenshot of this. It's the same as how you do HTD. Like you have done C programming, right? Everyone, of course. It's the first thing that, and is the first thing that, boggles our mind. What is this programming language? Okay, while we are in college. So, while file handling we do in C is the same as here. You just do get file storage, and then, put all those things inside, just like C. You can store 200 MB, you can store 500, 1 GB and all those things just inside, like you store on a hard drive. So, it's just that. Another, you can go back, it's, okay, this one. Another is LLMs. So, literally, we have like while I'm investing in one of the projects from Bits Pilani, there was one of the guys who was like, have you heard about those applications which we upload a video, let's say I upload my video, and then we are like clicking my video, and then it translates that into a, B-roll images, some kind of animations, all those things, right? So to add emojis, he was using Chat GPT, like just to add emoji. He's using a big, humongous model just to add, emoji at the end of the line to, do the sentiment analysis. Is it a good way of doing that? Yes or no? Yeah. We are just wasting the resources for just one byte of, emoji coming in. So you can actually use, some sort of model, just analyze and give me an image. Because most of the times, users don't care about what emoji is at the end, unless it's, I'm sad and it's showing a happy emoji at the end. So other than that, it's all good. So we can, get a model of 40 MB. We can host the model. So that's the first part. And everyone is doing it, right? Even ChatGPT, even Microsoft, everyone is doing the same thing. Now, what we can do, we are using running the calculations on that. Go back, okay. Now we can host the model. What if we can host the model inside our web browser itself? How are we going to host the model? I just told you the solution. How are we going to host a 40 MB model? Origin private file system. Origin private file system, right? Because IndexedDB is just a JSON representation of whatever you have. So if you want to run the calculation, we can use WebAssembly for tough calculation. Everyone heard about WebAssembly and all those things? Yes or no? Okay, so WebAssembly is basically we are converting binary formats into our web browser. You can go further. Now, what about web worker? Because WebAssembly takes some time to load, but web worker doesn't. So it's actually very simple. Whatever browser that we are running, it's all calculations. And in Java we have threads, right? Everyone learned Java and all those stuff. In that we have a concept called thread in computer science. So we are using web worker for that. Now there is a bunch of API. Now you can quickly see what APIs we have. Just a second. We can quickly see what API we have. So you can search over Project FUGU. All right. Here you can showcase the web capabilities that we have. Project FUGU showcase. And there you can see whatever. Now you see in Android, native Android, we used these things. Absolute orientation controller, all these things. So you can actually do right inside the web. Now, if you see background fetch, it was in native Android, it was not in web. Now we have background fetch as well. Like it's automatically going to sync from the background. Caching, badging, file handling, gyroscope. It's in game dev. Like we can use gyroscope as well. Payment requests. And then we also have this thing called, we can use our phone locks for logging into our web applications. Then we have web HID. Web HID is basically just, we have some of the game controllers that Unity users use, such as Xbox and all, which are not by default compatible in, web. So we can use web HID to do all those things. So you see, web has really evolved to, convert or deliver that web experience using AI models to the users. All right. So we have a bunch of things over here. Now moving ahead. So now we are at the end. And let's just quickly, go through all the things. So first, how we're going to do the research? We're going to stand on the shoulders of the giants. We're going to take the free research papers that we have on archive and all those things, papers with code. Then we're going to create a model of that. If it's, let's say, model is of, let's say, a short model, let's say 40 MB, 60 MB, we can just host it inside, the web browser. And then we can, we can make things really simple for the client and our servers as well, because if it's on the client side, we don't have to incur any costs. Then after we have created the model, we can just deliver that experience using Project FUGU. And I've just showed you all the UI stuff that we have, all the web stuff that we have. And it's, really, if you just learn about Project FUGU, it's, we see that web is kind of, everyone is saying that web is, web has a downfall, web is saturated and all those things. After, web engineering came into the picture, everyone is just doing API calling and creating the UI, API calling and creating the UI. But these is what companies are looking for. This is how you can, doing the engineering way, we can save the cost at the client side, we can deliver a smooth experience to that. All right. So this is all. Now, I hope everyone is clear with all the things. I have given you the homework just as we do in schools. All right. So if you have any questions, then you can ask. Any questions? Yeah. Yeah, using web GPU. Yeah, I actually showed you all the list. So if we, do anything, like you can think of any sort of thing that you have in mind, you can just look it up over here. So downloading the model, I already showed you origin private file system. Then if you want to use CUDA, you can just use web GPU for that. All right. Any more questions? Yep. Yeah.
For LangChain. We have LangChain models to
Yeah.
connect multiple
Yeah.
models, right? So do you use any specific libraries to run that in client side?
So that I know the question. So you want to, let's say, use multiple different
Yeah.
models
Yes, yes.
inside like origin private file system,
Yeah,
right?
correct.
That's the question.
Yeah.
So origin private file system, actually LangChain is a complex process than origin private file system. So whatever models that you want to do, let's say you have 3 models, right? Origin private file system is just like a directory. You can think of it, yeah, you can think of it just as this. You can think origin private file system like this file explorer over here, right? So we have different folders over here. You can actually create those folders. Inside that folders, you can create those files, all right? So not even 3 models. You can actually do many models. You can actually categorize them. Okay, this is UI. Inside that, I have 3 models. This is, what else? Hardware. I have 3 models there. So you can, just think of it as a file explorer, and you can do folders making, deleting, and all those operations. So that's origin private file system. And IndexDB is just JSON, so you can't do much over there.
And even the JavaScript libraries, we can by default download some models. Right?
Yeah.
So that also uses open private system internally.
It downloads it into the cache, not in the origin private file system. So whenever you do control refresh, it downloads it again. But using origin private file system, some of the applications are there that are using. That is Photoshop system. That's why Chrome storage, if you look at, it's 2 GB, 3 GB. How is that? So that's origin private file system. Yes, it uses that. Okay. Any more? Yeah.
Can we build a AI agent through this model for a GPT agent, for example, for outbound marketing, scrap the LinkedIn, send personalized cold outreach?
Yeah.
Like agents model can we build?
Yeah. How big is your agent model?
So agents for outbound marketing, I'm asking. For example, clay.com, similar to Clay or similar to
Okay, so you want to build a model.
without using API. So
Yeah, you
build
can
an
build it.
agent, we need to use OpenAI API.
Yeah, so-
is it possible through this method to build
With the research going method. Yeah, it's possible because whatever agents that you are using it's actually the representation of the research papers that we have. And the APIs you are using is just the same. Someone has used this technique that I just told you, and then he's giving you as an API. Just I created Navya, and then I ran it on CPU, not even in GPU, and I gave it as an API with the cost of GPU, but I am using CPU. You know, you can do all the things. And I showed you that papers with code. You can actually go to that resource. That's the exact resource that you want to look for. Papers with code has all your answers over there. Yep. No, Chrome extensions doesn't have access to OPFS because it's not secure. Because if I created an extension, I can just look up at all of your. No, because in Chrome extension we already have that capability with not OPFS, but inside Chrome extension you can put all your stuff over there. So we don't have, and OPFS is actually domain specific, which means if it's Photoshop, then it's related to, let's say Photoshop, then Photoshop, think of Photoshop.com as a computer, and then we have that file explorer over here. So every site has its own OPFS. Yeah.
Hello.
Any more questions? Yeah. Okay.
What if I update weights, real-time weights? Shall I talk in Tamil?
Sorry?
Tamil பேசலாமா? தமிழ்ல பேசலாமா?
Can you translate that?
Actually, you said நீங்கள் உங்கள் மாடலை வந்து நீங்கள் வெப்பில் வந்து ஹோஸ்ட் பண்ணலான்னு சொன்னீங்க. ஸோ 40 MBன்னு சொன்னீங்க. அது வந்து ரியல் டைமாக என்னால் வெயிட்ஸை வந்து அப்டேட் பண்ண முடியுமா? ஸோ we can change the weights in real time.
He's asking whether you can configure the weights, when you're
For
using the model.
you said inference.
Whether you can configure your weights locally.
Okay, so let's say we have a model .h5 and you want to, we have the weights and you want to, real time modify the weights on the fly.
Like
while
fine
we,
tuning, like fine tuning
on our web browser.
on the fly.
See, we can do it. I tried to do that, but it's like when we are fine tuning on the fly, fine tuning is like a really humongous resource consuming process. All right. So if you fine tune on the fly, then it's not going to work because I'm not successful in that. When I had a very big computer, like a server grade computer, then you can do that. Because client side is just using client's resources that we have. So if you fine tune on fly, you have to make sure that the client has that server grade computer. The other thing is that if you want to modify the weights, you can actually use WebSockets. You can use OPFS and then you can do the processing on your server and then you can do the stuff. So the solution to your question is use OPFS, use WebSocket and then use your computer and then just modify the weights.
Just will update the model. Just will update the model.
It will update the model because OPFS is just writing read and write to the file storage. Think of it just as a C language, file handling. You take the bytes and then you just update there. Okay? Yeah, someone from here? Yeah. I can't listen. Okay. Can I just go some? Okay.
Like rather than hosting our model in Hugging Face and
Yeah.
then using it as an API in a web app,
Yeah.
will there be any performance? Will the performance be up to the par while we are running it on client side?
Yeah, at client side, actually the performance is good.
Good.
Rather
Okay.
than, you can think of that, like when we are requesting to the API then coming it. But, I already told, these models are small models, not like a 1 GB, 2 GB, 7 GB LLMs model. It's not gonna run, okay? Because to run 7 GB model, you know what server requirements that it takes. So rather than that, you just use that. If, let's say this scenario in which we are just predicting an emoji, some, that can be run on, let's say, with 200 MB RAM, 300 MB RAM, that you can use inside OPFS. And that's actually performant than using an API.
Okay. Fine.
Okay. Yeah. Downloading the model. Yeah. Yeah, you can find the file. No, I'm not talking about the paid models. Let's say the ChatGPT is just hosting the VA encoder. Yeah, because some of the tough calculations we can just do on that particular client side, and then you can go to the server side, and then you can distribute some of the compute cost over the server rather than doing all of the things. Just do some of the things at the web worker, some of the things there, and then you can go over there. All right. Any more questions? Yeah, the slides will be shared.
Do we have any JS specifically for our Gemini models? Like we have a TensorFlow JS, right? To
Yeah.
run everything on the Angular application
Yeah.
or front end. So do we have any specific JS library for Gemini models?
For Gemini, we have APIs.
Okay, only APIs.
Yeah, we have
I mean,
APIs.
If I use APIs, again it runs on the server, right? So there will be some latency issues.
No, Gemini has its own server,
Yeah.
like just an API. For Gemini, we have Gemma models. We have also Gemma Mini, which is of, let's say, 80 MB. We can run it on OPFS. And then some of the big models, we have to use the server approach for that.
Okay.
All right.
Yeah.
Can you take a video? Okay.
Yeah, so the question I had is two-part. One is like, if let's say I open a site,
Yeah.
I download the model to OPFS,
Yeah.
and let's say the user never logs into the site again.
Yeah.
Is there any way that I can remove the files? Let's say I want to delete the model for all the users.
Yeah.
Is there a way to do that? And Okay, I can finish the second question also.
Yeah. That particular thing is actually background fetch.
Okay. No, not background fetch, like a background delete.
Yeah. That's there. I just showed you that thing. So you can actually go to this particular API. All the answers are over here.
Okay.
So the answer is where is it? Okay. Background periodic background sync. This one. Periodic background sync.
Okay. Yeah.
So you can check the date, and based on the date, you can just remove every model that we have.
Okay, thank you. The second part is that we have done some projects for the rural areas where
Yeah.
our internet connection is like very slow,
Yeah.
or the device is not to the par standards.
Yeah.
So do you have any ways to like improve the performance, or are there any performance limitations to OPFS?
No, OPFS is just like a file browser that we have. It's rather than downloading. When we are downloading the model, let's say you might have used this Tesseract to convert this image to handwritten images. So it downloads the model, but it downloads the model in the cache.
Okay.
With OPFS, you can download the model inside the browser and it stays there.
Okay.
So that's the difference, and it's all the same.
Okay, thank you.
All right. Any more questions? Okay. Train Navya on GPU and that runs on CPU. Yeah. Yeah, there we use fine tuning because before GPU we also have models, right? We do have models that runs on CPU. We just fine tune that particular thing. We reduce the data set. We use filtered data set. Using Utenet architecture, we remove some of the layers, such as 512, which takes a lot of memory. So we do all those experimentation with the architecture, and then arrive on some of the things. And we also have auto train on all those things to fine tune the model. As far as I have, let's say on GPU, a big model with many data, like many data points, take let's say 3 seconds. Mine is like 4 or 5 seconds, something like that, or 6 seconds sometimes when the prompt is complex. So it's that. Yeah. Firefox have. You can look at MDN, and OPF is not a new thing. It's just a hidden thing because everyone is busy in calling APIs, making front end. Nobody is basically aware about the web engineering part. So it's that the difference. OPF was always there. Conclude. Okay. So I'm around. I'm here only. So you can catch me up on the.
Post the LinkedIn account.
Yeah.
You can contact me through LinkedIn.
Sure. Okay, I'll come to you just now. So just a quick video. Whenever we have something like that, I used to do a STEM crafter shout out, or we can shout out GDGChennai. So that's a major thing. So can we do that?
Yeah.
Okay. So
Everybody get ready. We'll go on a countdown.
1.
Please focus to the camera.
So I'll post it on my LinkedIn handles as well. So we'll do a GDGChennai shout out. Okay. So 1, 2, 3. GDGChennai. Okay, cool.